Hi everyone. In today's video, what I want to do is to review the hyperbolic function, and we're going to do so using 6 different exam style questions, right? So what we have on screen is we are told to consider the function f of x is equals to 120 divided by x plus 3, right? And this is minus 4, right? The first question asks us to determine the coordinates of the y-intercept of f, right? Now, before we go into the first question, let's just recall for ourselves, right, the general form of the hyperbolic function. Okay, so we know that the general form of the hyperbolic function can be given by f of x is equals to a divided by x minus p, right, plus q, right? So from here, we know that our a value just tells us the shape of our hyperbolic function, the q value gives us our horizontal asymptote, and the p value gives us our vertical asymptote, right? Now, if we compare this general form to what we are given, right, we can see that in order for us to immediately see what the p value is, we can rewrite this as f of x is equals to 120, right? And we want to make it match this, right? So then we have to write this as x minus negative 3, okay? And then we still have that minus 4, right? So then from there, we can see that our p value is negative 3. Okay, so this is the value of q, and that is the value of p. Right. We all know also that another way to get the value of p is just to set your denominator equal to 0. And if we had to do that, so we have x plus 3 equal to 0, right? That will give us x is equals to minus 3, and minus 3 will be our p value. Okay. Right, so what does this mean? Well, it means that our original function, right, so the mother function 1 over x, right, first of all has been stretched by a factor of 120, right, and then the next thing that they did to it is that they moved it 4 units down, right, and then 3 units to the left. Okay, so let's go into question number A. Right, so in A, they want us to determine the coordinates of the y-intercepts of f, right? So we all know that we always start off by stating what we're doing, and we're just going to say for y-intercept, okay, we're going to set x equal to 0, okay? So then when we set x is equals to 0 in our function, right, we can even say let f of x equal y. Then we'll have y is equals to 120, right, divided by, well, we want to set x equals to 0, so we'll have 0 plus 3, and then we still have minus 4, right? So then y is equals to 120 divided by 3, and then we still need to subtract 4 from that. I'll just evaluate this on a calculator. Okay, so we have 120 divided by 3, and then we need to subtract 4 from that. That gives us a y-intercept at 36. Okay, so since we are looking at the coordinates, right, of the y-intercept, well, we know that that's therefore going to be a y-intercept at the point 0, 36. So there we go. We've now successfully determined the coordinates of our y-intercept. Right. So next question. Question B is asking us to find the coordinates of the x-intercept of f, right? So now we always start off with what we're doing, right? So for x-intercept, right, we all know by now that we need to set y equal to 0. Okay, and then we're going to let f of x equal y. So then from there we have that y is equals to 120 divided by x plus 3 minus 4, right? We're now going to set y equal to 0, and that's going to be equals to 120 divided by x plus 3 minus 4, right? So then we can add 4 to both sides, right? And then also simultaneously multiply by this denominator. So then we'll have 4x plus 12, and that's going to be equals to 120, right? So then we'll have that x is going to be equals to 120 minus 12 all divided by 4. So we'll just quickly use a calculator to determine that. So when we do that, we get that our x-intercept is at x is equals to 27. Right, so then we have that the coordinates of the x-intercept of f is located at the point 27, 0. Right. Question C. We are asked to sketch the graph of f, right, and clearly show the asymptotes, the axis of symmetry, and the intercepts with the axes, right? So now in order for us to sketch the graph of f, right, then it will be useful for us to use this equivalent form of our given equation, right? Because from the equivalent form we can see our p and q values immediately, right? So which means that we already know that we have a horizontal asymptote at -4, right? So since this is a sketch, we're just going to place these things on our Cartesian plane. So I'm just going to draw a horizontal line, and I'm going to name this line y is equals to -4, and then I'm going to draw a vertical line at -3. Okay, we're going to label this x is equals to -3, right? And then we need to plot in our x-intercept and our y-intercept, and we determine that to be at a point, well, let's just write it down. The x-intercept, right, was at the point 27, 0, and the y-intercept was at the point 0, 36, and we determine these coordinates from question A and B above, right? Now the last thing that we can check is this value of A, right? And we see that A is greater than 0, which means that we are going to be in our positive quadrants, and the positive quadrants is your first quadrant and your third quadrant, right? So I'm just going to quickly sketch in the graph of f. Okay, so here's a sketch of the graph of f, right? And then I just need to indicate, like they wanted us to show, right, the intercepts with the axes. So I have to indicate this coordinate as being 36 and this coordinate as being 27, right, for our x-intercept, right? So we have already shown the intercepts with the axes, right? We've clearly shown the asymptotes. The only thing that's left is to show the axes of symmetry. Now for the axes of symmetry, right, we know that we're going to have two of them. One of them is going to have a positive gradient and the other one is going to have a negative gradient, right? So let's start off with the axis of symmetry that has the positive gradient, right? That's going to be given by the equation y is equals to x, right, minus p plus q, right? So then we can substitute in our p and q values, right? So then y is equals to x, right? And then we've got negative 3 for p. So then that's going to be a negative times a negative, giving us a plus 3 over here. And then we're going to have a minus 4 as a value of q, right? So then we have positive 3 and negative 4, which is going to be a negative 1. So y is equals to x minus 1, right? Okay, and there is the sketch of this first axis of symmetry, right? It has a y-intercept at negative 1 and a x-intercept at 1. Okay, this is the equation y is equals to x minus 1, and this is an axis of symmetry. Okay, so now let's find the axis of symmetry that has the negative gradient. We've already determined the one that has the positive gradient. And that's going to be given by the equation y is equals to negative x plus p plus q, right? So we're going to have y is equals to negative x, right, plus p, well, p is negative 3, plus q, that's negative 4, right? So this becomes y is equals to negative x minus 7, right? So then this is going to have an x-intercept at negative 7, y-intercept at negative 7, right? So let's draw it in. Okay, so this has the equation y is equals to minus x minus 7, right? It has a x-intercept here at negative 7, right? And a y-intercept also at negative 7. Okay, and yet again, this is an axis of symmetry. Right. Notice that the axis of symmetry always intersect over here where the asymptotes intersect, right? So that point is the point negative 3, negative 4. So if you wanted to, you could determine the equations of the axis of symmetry using the equations y is equals to a positive gradient x, right, plus c, and the equation y is equals to a negative gradient, so negative x plus c, right, and then substitute the point negative 3, negative 4 into each of these equations and determine your c values, right? And you will get that your c value is minus 1 and the other c value is minus 7. So that's another method that you can use in order to find the equations of your axis of symmetry, right? So then we go back to the question and we see that we've we check, that we've answered everything, right? So we've done a sketch of f, right? We've shown the asymptotes, yes we have. We've shown the axes of symmetry, yes we have. And we've also shown the intercepts with the axes, yes we have. Okay, so that is basically a sketch of this function f of x. Okay. Next question, question D, right? We are asked to state the domain and the range of our function f, right? So now I have a little note on the side over here, right? So for the general form a divided by x minus p plus q, right? The hyperbola will have the following domains, right? So it's obviously going to have a domain of x values and elements of real numbers except for the x value at your vertical asymptote, right? So in other words, x cannot equal the value of p, right? And same thing for your range. Y is an element of real numbers, right? But y can't equal the y value at your horizontal asymptote, right? So then we can then work with this equivalent form of our function f, right, that we've written here on the side, okay, which is essentially the same equation as what we were given, right? It's just that from here we can see very clearly what is our p value and what is our q value, right? So then we can then go ahead from this knowledge and state that the domain, right, and this notation over here is called set builder notation, right? So the domain is equals to x such that x is an element of all the real numbers, right? However, x cannot equal a value of minus 3 in our case, right? That's where we had our vertical asymptote, right? Another way that you can state this answer if you wanted to, right, or you can state this using interval notation, right? So you can say that, well, you are looking at all the x values, right? Coming in from the left hand side, you're looking at all the x values from negative infinity, right? So you're going to have up until you get to this x value of negative 3 that we can't attain, right? We'll close that bracket, and it's also not included because that's where we have our vertical asymptote. Then we have, together with that, or union, right, all the solutions after that. So from negative 3 all the way up to positive infinity, and that's also going to be a round bracket, right? So if you wanted to give your domain in interval notation, that's how you would do it. Okay, let's now state the range. So the range is going to be equals to y such that y is an element of real numbers. However, y cannot specifically be the value of minus 4. Okay, again, if you want to use interval notation to state this, right, you can just simply say, sorry, I forgot over here, so x an element, right? So you can simply just state y is an element, right, of the solution set. Okay, so y is going to be from negative y, right? If you imagine the Cartesian plane, right, you're going to be going upwards, right, from these negative values of y until you get to that negative 4, but you can't include that negative 4, so it's going to be negative infinity, right, all the way up to this value of negative 4, not included, and then together with all the other values after that. Okay, so it's going to be negative 4 to positive infinity. Okay. Question E. We have to find out for which values of x is f of x, right, less than or equal to 0, right? So now basically what we're looking for here is where our function, right, if we just quickly look at a Cartesian plane, right, we know that f of x is just the y values, right? So if we're looking for y values less than 0, we're looking for negative y values, and negative y values stay underneath, right, the x-axis, right? So over here in this area, that's where we get negative y values. Okay, and on this line, right, so basically the x-intercept line, right, that line is also given by the equation y is equals to 0. Okay, so if we wanted to equal 0 as well, we're also looking for where our function intersects the x-axis, right? So we're going to need our graph again. Okay, so I'm just going to move this theory a little bit to the top, right? And we just need our graph again. Okay, so here's a sketch of our graph, right? Now, when we look at the sketch of our graph, we'll see that these conditions that we're looking for, where the graph is below the x-axis or intersecting the x-axis, right, is everything over here, right? Let's just indicate it. Well, that is going to be all the x values, right? When we look at this condition where y is equals to 0, we see that that x value is going to be an x value of 27, because that's where we have an intersection with our x-axis, right? And then after that, the graph is in this gray shaded area for all of these x values greater than 27, right? And it's going to go up to infinity, right? So we're looking at all of that, including this x value here at 27, right? And then we have this space over here that is not in our required condition. We get to this x value of -3, right? And we see that for any x value of -3 and less than that, our graph is in this gray shaded area and is actually below the x-axis, so it has only negative y values. But then this x value of -3 is a vertical asymptote, so it's never going to touch that vertical asymptote. So basically what we're talking about is all these x values here from 3, but not including 3, so we have an open circle over there. And then we're talking about all these x values less than 3. Okay, so to write that down, usually these questions are just 2 marks. That's why it's much faster to just get the answer off from the sketch, right? So then for which values of x is f of x less than or equal to 0, then you're just going to state that for, right, x an element, right, and we'll write this in interval notation. Okay, so we are looking at all the x values from negative infinity, right, going up to this x value at -3, but not including that x value at -3 because that's our vertical asymptote, right? And then we have together with this all these x values on this side, right, from this positive 27, including that positive 27 this time, okay, and then all the way up to positive infinity, but not including infinity. Okay. Okay, so that's giving your answer using interval notation. If you wanted to, you could give your answer as an inequality, right? And what we would say is that f of x, right, is less than or equal to 0 when ever x is strictly less than -3, or when x, right, because this or means exactly the same thing as this union over here, right? So or when x is greater than or equal to 27. Okay, so that's one way to give your answer. That's a second way to give your answer. Question F, right? In this question, they want us to calculate the average gradient, right, of f between the values of x is equals to -3 and x is equals to -5. right? Now this is obviously just going to be the gradient of the line, right? The straight line that is passing through x is equals to minus 3 and x is equals to minus 5, right? So let's just find the corresponding y values for each of these points. So when x is equals to negative 13, sorry, I mean negative 13, and then we're going to have when x is equals to negative 15. Okay, we'll just evaluate this in the calculator. We'll just do this and say y equals, right? So let's go for the first one. Okay, so with the first one, we just take our equation of f of x and we substitute an x value of minus 13, right? And we get a corresponding y value of minus 16. So y is equals to negative 16, right? Let's check the second one. Right, so now for our second calculation, we do exactly the same thing in the calculator. It's just that now in place of x, we substitute negative 15 and we get a corresponding y value at negative 14. Right, so then after that, we can just say that we have the points negative 13, negative 16, and negative 15, negative 14, right? And we want the average gradient. Okay, and average gradient is just the normal way that we determine gradient. It's just going to be a change in y values divided by change in x values, right? And you just need to make sure that you always start with the same coordinates, right? So I'm going to use this negative 15, negative 14 as my starting coordinates. So I'm going to have negative 14 minus a negative 16. And that's going to be divided by negative 15 minus negative 13. Okay, so that's going to simplify to negative 14 plus 16 divided by negative 15 plus 13. Okay, so then this is going to be equals to, well, 16 minus 14 is going to be 2, and negative 15 plus 13 is going to be a negative 2. Right, so that gives us a gradient of negative 1. Okay. Last question deals with transformations, right? We have to write down the equation of a function g if that equation of g is the graph of f which has been shifted 2 units to the right. Okay. Now this over here, right, you just need to be careful about signs, right? If you look at your original, right, equation, right, we see over here we have this plus 3, right, and we know that whenever we have a plus 3, right, next to our x, right, we know that the graph has basically been shifted 3 units to the left. Okay, so if now they say that the graph has been shifted 2 units to the right, right, that obviously then needs to be indicated with a negative 2, right? So then we're going to say that g of x, okay, is going to be given by the equation 120, that is not changing, right? Okay, and then we're going to divide this, right, by x plus 3, and then we need to add this negative 2, right, to indicate this 2 units shifted to the right. Okay, and we still have this minus 4. Okay, so then g of x is going to be equals to 120 divided by x plus 3 minus 2 is going to be a plus 1 minus 4. Okay, so then that's the equation of g of x if g of x is the graph of f shifted 2 units to the right. Okay,